Hey everyone, and welcome back to the Deep Dive. Today we're going deep on something pretty huge, the original Bitcoin white paper. Bitcoin, a peer-to-peer electronic cash system. You all sent this in so I can tell you're as fascinated as I am by how this whole thing got started. It's like we're going behind the scenes of some magic trick, except this magic trick is real-world tech. We're going to break down the core mechanics, the big ideas. And trust me, even if you think you know Bitcoin, this deep dive just might surprise you.
Yeah, what's really cool about this paper is how it lays out this problem that we all kind of deal with, but we don't really think about that much?
Yeah.
Trust, like our whole financial system is built on it, right? We trust banks to handle our money, credit card companies to process payments, governments to regulate it all. But what if? What if we could just get rid of that need for trust? That's the question that Satoshi Nakamoto is trying to answer here.
It's like we just accept that this middleman system is how things have to be. But Nakamoto is like, hold on, what if we just rethought the whole thing?
Exactly. Like he starts by pointing out these limitations that we have with traditional e-commerce. Every transaction relies on a financial institution to be this trusted intermediary. And it works for the most part, but it's not perfect.
Right. What happens when a payment is disputed? Someone
Mm.
has to step in and figure it out. It takes time and money. And what about tiny payments? Like if you want to pay a little bit for online content, suddenly it's not practical because of all the fees.
Right. And then there's always that risk of fraud. Merchants have to be super careful. Customers have to deal with all these security checks. The system works, but it could be better.
And then Bitcoin comes along.
Right.
This paper is proposing a system built on this cryptographic proof instead of trust, allowing you to do direct peer-to-peer transactions. No more middleman slowing things down and taking a cut.
The real innovation is this concept of an electronic coin as a chain of digital signatures. Imagine like a digital ledger. And every transaction is cryptographically linked to the one before it. This unbreakable chain of ownership.
So instead of a bank verifying my transaction, it's this chain of signatures that's proof.
Exactly. But this brings up a classic problem, right? How do you stop someone from just copying and pasting a coin and spending it twice? It's a double spending problem.
It's like trying to make a copy of a dollar bill and spending both. Doesn't work in the real world. But digitally, things get a little messy.
Right. To stop that, you need a way to set a timeline for transactions, to know which one came first. Traditionally, you might rely on something like a timestamp from a trusted source. You know those old newspaper ads where people published a hash to prove they had a piece of data at a certain time?
So it's like having a timestamp on a receipt to prove when you bought something. But how do you do that digitally without having one central authority?
That's where Nakamoto brings in this groundbreaking solution, proof of work. It's this digital competition to solve a really hard computational problem. And whoever solves it first gets to add the next block of transactions to the chain. They get to timestamp those transactions.
Okay, so it's not just about verifying transactions. It's about securing the whole system.
Exactly. Because proof of work takes so much computing power. It becomes really hard and expensive for anyone to try and mess with the blockchain. They'd have to redo all that work for every single block after the one they changed. It just doesn't make sense to cheat.
So the longer the chain grows,
Yeah,
the more secure it becomes.
right.
But can you walk me through how this all actually works in the network?
Sure. So first, new transactions are broadcast to every node on the network. Each node is just a computer running the Bitcoin software.
So it's not like there's one central server handling everything. It's more like all these computers working together.
Exactly. Each node collects these transactions into a block. And then they all start trying to find the proof of work for their block. You remember that computational puzzle we talked about?
So it's like a race to solve this puzzle.
Pretty much. The node that cracks it first gets to broadcast their block to all the other nodes. And now here's where consensus comes in. The other nodes will only accept that new block if all the transactions in it are valid, and if they haven't already been spent. And how do they show acceptance? By starting to work on the next block in the chain, building on top of that new block.
So it's this chain reaction of verifying and building, with
Yeah.
every node helping keep the system secure.
Exactly. But what happens if two nodes find the proof of work at almost the same time? You get a fork in the chain.
A fork.
Don't worry, the system is designed to handle this. Nodes always work on extending the longest chain they know of. So that fork gets resolved quickly as soon as one branch becomes longer.
It's like the network is constantly correcting itself, always moving toward the most secure version of the transaction history. But how does the whole network stay motivated to do all this work?
Well, you need some incentives. That's where mining rewards and transaction fees come in. The very first transaction in each new block is special. It rewards the block creator with brand new Bitcoins.
So that's what motivates people to contribute their computing power, the chance to earn some Bitcoin. It's like digital gold mining. But instead of digging in the dirt, you're crunching numbers.
Exactly. And as more Bitcoins get created, transaction fees become a bigger part of the incentive. Users can add a small fee to their transaction, and that goes to the miner, who includes it in a block.
So this makes sure that even when all the Bitcoins have been mined, there's still a reason for people to keep the network running.
Right. But it's not just about the money. Nodes are incentivized to stay honest. Remember, the value of Bitcoin is tied to the integrity of the whole network.
So if you try to cheat the system, you're hurting the value of your own holdings. That's a pretty clever way to keep things in check.
It is, and that's really just the start. We haven't even talked about things like Merkle trees for efficient data storage,
Okay.
or how users can verify payments without running a full node.
Okay, I'm really interested to hear more about that. Let's dig into those in part 2 of our deep dive. Okay, so we're back, ready to keep going deeper into how Bitcoin actually works. Last time we were talking about proof of work and how that secures the network. But you also mentioned something about Merkle trees and efficient data storage. That sounds pretty interesting. Can you explain that a little more?
Yeah, so as the Bitcoin blockchain grows, with every new transaction, storing all that data could become a big problem, especially for people who don't have super powerful computers or tons of storage space.
Yeah, I can barely keep up with all the photos on my phone, let alone the whole history of Bitcoin transactions.
Right, but Nakamoto knew this would be an issue, and he came up with a solution: reclaiming disk space. By basically getting rid of information about transactions that have already been spent.
Okay, but isn't that risky? If you're deleting data, how do you make sure everything stays accurate and secure?
Well, that's where Merkle trees come in. It's like a really efficient summary of all the transactions in a block. Instead of storing every little detail of each transaction, you use a Merkle tree to create this single fingerprint that represents all that data.
So it's like having a receipt for something you bought even after you've used the item. You don't need all the details anymore, just proof that the transaction happened.
Exactly. That way you can get rid of the spent transactions, but you can still verify that they were part of the blockchain if you need to. This stops the blockchain from getting too big, and it lets users verify payments without having to download the entire history of transactions.
That makes sense. It's like finding that sweet spot between security and efficiency. But what about people who don't want to run a full node? You know those computers we talked about that store the entire blockchain? Can they still verify transactions?
Absolutely. That's what simplified payment verification is for. We call it SPV. It's kind of like a lightweight version of the Bitcoin software. You don't have the whole blockchain,
Right.
but you can still verify transactions.
Okay, how does that work?
Let's say you want to confirm a transaction. With SPV, you can ask the network for the longest chain, and you just ask for a little piece of information called a Merkle branch. This branch connects your transaction to its block. It proves that it's part of the main chain.
So it's like asking a friend to confirm something for you. Instead of doing all the research yourself, you're trusting that the network is giving you accurate information. Pretty clever.
Yeah. Now, we've talked about trust in traditional systems and how Bitcoin tries to get rid of that need for trust. But another big part of any financial system is privacy. What good is digital cash if everyone can see every transaction you make?
Right, it seems weird to have a financial system where everything is public. Doesn't that defeat the whole purpose of privacy?
It's a good point. And Nakamoto talks about this in the white paper. Bitcoin gets some level of privacy by separating your identity from transactions. Instead of linking transactions to real names, it uses these things called pseudonymous public keys.
So it's like using a nickname online. You can do things and share information without revealing who you really are.
Exactly. Everyone can see that a transaction happened, but they don't know who sent or received the money. But complete privacy is hard.
Because if you use the same public key for a bunch of transactions, people can start to see a pattern and figure out who you are.
Right. And Nakamoto suggested using a new key pair for each transaction to make things more private. But even then, with more complicated transactions, like ones with multiple inputs, it's still possible to link those back to one person.
It sounds like it's tough to balance transparency for security with keeping things anonymous. Is there a way to have both?
It's a challenge. A lot of people are working on ways to improve privacy in Bitcoin and other cryptocurrencies. But finding that perfect balance is tricky.
But even with these privacy questions, Bitcoin still seems pretty secure. What would it take for someone to actually hack the network
Huh.
and like rewrite the blockchain?
That's where proof of work really shines. To change the blockchain, an attacker would need to control most of the network's computing power. And that's really hard and expensive to do.
It sounds almost impossible. Didn't Nakamoto do some calculations about this? Like, what are the chances of someone actually pulling this off?
He did. He used this idea called the gambler's ruin problem. Imagine a gambler keeps betting until they either win everything or lose everything. The longer they gamble, the harder it is for them to come back from their losses.
So with Bitcoin, the game is like the race between the honest chain and the attacker's chain.
Yeah, the attacker is betting against the whole network, and the odds are not in their favor. As more blocks get added to the honest chain, the more power the attacker needs to catch up, and their chances of winning get smaller and smaller.
So the longer Bitcoin is around, the more secure it gets. It's like a system that's designed to make it really hard to attack.
Exactly. And that's not even thinking about the incentives. It's way more profitable for miners to play by the rules and earn rewards than to try and cheat the system.
It's like Nakamoto built in all these 60 measures to make sure the system can work on its own. It's amazing how he thought about all these potential problems.
It is. That's what makes this white paper so groundbreaking. But it's not just about the technical stuff. It's about what this technology means, how it changes how we think about money and technology. It sparked a global movement and a ton of new ideas in cryptocurrency and blockchain.
It's like Nakamoto opened this door to a whole new world.
Exactly. And the impact goes beyond just finance. These ideas of decentralization and transparency and trustless systems, they can change all kinds of industries. Think about supply chains, voting, even how we prove who we are online. Blockchain could change everything.
It's hard to imagine everything this could mean. We started by looking at the details of Bitcoin, and now it's like we're seeing the bigger picture.
That's what we're going to explore in the last part of our deep dive. We'll look at some of the challenges Bitcoin faces and what kind of impact it could have on the future of finance and beyond.
All right, so welcome back to the deep dive. We've spent the last two parts really getting into the nitty-gritty of Bitcoin. Proof of work, Merkle trees, all that. But like anything new and groundbreaking, there are always going to be some criticisms and challenges.
Yeah, for sure. It's important to look at Bitcoin from all sides, to understand both what it can do and where it might fall short.
So let's talk about some of those criticisms. One I hear a lot is about how much the price of Bitcoin goes up and down. It's known for being pretty volatile, which can be scary for investors and make it hard for businesses to actually accept it as payment.
Volatility is definitely something to consider, and Nakamoto even talked about it in the white paper. He thought the price would be unstable at first, until enough coins were out there.
But even years later, the price is still all over the place. Does that mean Bitcoin will never be stable enough to actually be used as a regular everyday currency?
That's a good question. For a currency to be widely used, people need to trust that it's going to hold its value. But remember, Bitcoin is still pretty new compared to currencies that have been around for ages. It's like comparing a brand new company to one that's been around for centuries. There are going to be some bumps along the way.
So are you saying it's too early to say if Bitcoin will ever stabilize?
I think so, yeah.
Yeah.
Some people think as more people use Bitcoin and more big institutions get involved, the volatility will naturally die down. But we also have to think about regulations, which are changing all the time.
Right. Governments all over the world are trying to figure out what to do with cryptocurrency. Some are embracing it, some are banning it. All that uncertainty makes it hard for people to know what to do.
Absolutely. And then there's the problem of scalability. Bitcoin is designed to be secure above all else, but that comes at a price. Transaction speed.
So even though Bitcoin is decentralized and secure, it can take a long time to process transactions.
Yeah, the proof of work process takes time. Even though it's super important for security, the network can only handle so many transactions per second.
That sounds like a real bottleneck. Is there any way to make Bitcoin faster without messing with those core principles?
There are some ideas out there. People are working on it. Some want to increase the block size. Others are focusing on these things called second-layer solutions, like the Lightning Network.
So it's all about finding ways to make things more efficient without sacrificing the fact that Bitcoin is decentralized.
Exactly. Finding the right balance between scalability, security, and decentralization. It's key for Bitcoin to succeed in the long run. But there's one more criticism we should talk about, one that's gotten a lot of attention: energy consumption.
Yeah, the environmental impact of all that computing power needed for proof of work.
Right. Proof of work uses a ton of energy, which has people worried about its impact on the environment. especially with climate change.
So is Bitcoin always going to be an energy hog?
Not necessarily. People are exploring other ways to reach consensus that are more energy efficient, like proof of stake, which doesn't need as much computing power.
So finding ways to secure the network
Yeah,
without using so much energy.
exactly. And some Bitcoin supporters say that it actually encourages the development of renewable energy because miners are always looking for the cheapest electricity, so they might be drawn to solar, wind, or hydropower.
That's interesting that Bitcoin could actually lead to more green energy. It seems like even though there are these criticisms, people are coming up with solutions.
For sure. And even with these challenges, there's no question that Bitcoin has started a revolution. It's changed how we think about money and technology. It's a global movement with tons of innovation in cryptocurrency and blockchain.
It's like Nakamoto opened up this whole new world of possibility.
Yeah. And its impact goes way beyond finance. These principles of decentralization, transparency, trustless systems, they could change so many industries. Think about supply chain management, voting systems, even how we verify our identities online. Blockchain could change everything.
It's hard to imagine everything this could lead to. We started with a white paper about Bitcoin, and now we're talking about how it could change the way our whole digital world works.
That's what's so cool about these deep dives. We start with one thing and end up talking about the future of technology trust and how our society works.
It's really exciting. It's not just about understanding Bitcoin. It's about understanding all the potential that it unlocks.
Exactly. It's about realizing that the future is happening now, and we're all part of it.
So that brings us to the end of our deep dive into Bitcoin. Hopefully this got you thinking and inspired you to learn even more about this incredible technology.
Keep exploring, keep asking questions, and who knows, maybe you'll be the one to come up with the next big idea.
Thanks for joining us on the deep dive, and until next time, keep those curious minds engaged.